Are you AI ready or are you AI challenged? Whatever may be the cause, but not riding on AI platform may bereft you of cost savings and smart decision making. Good evening, ladies and gentlemen. This is Ruben Fernandez from ET Edge, and it gives me immense pleasure in welcoming you all to the Economic Times live webinar on the theme of Unleash the Business Potential of Your Data. This webinar is brought to you by ET Edge in association with IBM. Dear friends, according to IDC, about 23% of businesses are struggling to find out the right software or algorithms for AI solutions, while 77% of their infrastructure is a challenge in AI adoption. Many companies are fraught with exploiting the advancements in AI technologies, as moving data to a public cloud platform is expensive, or regulations prevent them from using it. This webinar will help you learn how to climb the ladder to AI with a multi-cloud platform that makes existing data ready for AI, creates a trusted analytics foundation, scales insights on demand, applies machine learning everywhere, including the data behind firewall. With those words, I would like to hand over to Mr. Gunasekaran Chilappan, Director Analytics, IBM Asia Pacific, and Mr. Nishant Arora, Analytics Marketing Leader, IBM Asia Pacific, to take you through an entire journey on multi-cloud platform to unleash the potential of its data.
Thanks, Ruben, and welcome everyone to this exciting discussion today on how we can unleash the power of data in your enterprise. We're witnessing almost unprecedented success in organizations driving digital business. And now almost all mature organizations are in different stages of different digital transformation. If you look at stock price performance, companies with digital transformation at the core of their business strategy are performing at a much higher pace than companies that don't. And the results for digital transformation are for all of us to see. There's a 9.5x improvement in product quality, 5x more likely to see improvements in cost reduction, and 1.7x more likely to see improvements in user and employee satisfaction. And when we look at it all combined, we're likely to see 1.6x improvement in customer intention, making digital transformation one of the most critical initiatives of this decade. And if we look at what is at the core of digital transformation, it's essentially data, which is growing at an unprecedented pace. And this data is enabling new business models and is what is going to help you move to the ultimate vision of deploying or harnessing the power of artificial intelligence. Our studies, and having worked with a lot of clients today, we see only 15% of the organizations are getting what they need from their data. And we try to share a data maturity curve with our clients. And having worked with thousands of clients globally, what we see is that many of us have started using data to optimize operations. Example, we worked with Rio Tinto and helped them save millions and millions of dollars in supply chain. Many of us have modernized our BI and data warehouse environments as well, and we're seeing a lot of value from those as well. But very, very few of us today have empowered each and every employee in our organization to have the data they need to make better decisions. Now, for a typical Fortune 1000 company, just a 10% increase in data accessibility would result in more than $65 million in net additional income. Now, this is not just applicable to Fortune 1000 company as well. This goes down. You may not see $65 million additional net income a year if you're a small and medium enterprise, but having access to the right data when you're making decisions is critical for you to succeed. And then the evolving global regulatory landscape means that all businesses must establish data governance as a corporate discipline and a requirement that must be taken seriously. And finally, there are a few organizations, and we are increasingly seeing them being way more successful, who are using data to transform their business. They are entering into new business models, harnessing the power of data and the improvements in the AI technologies that we have today. As you said, AI promises to unlock the value of data in totally new ways. Now, if you look at it, there is right now a horde of unleashing the power of AI, and we're seeing huge amount of investments in AI. 85% of CIOs would be piloting AI programs, and closer home in India, over the last 1 year, data scientist demands grew 417% in just 1 year. We have hundreds of AI startups getting millions of dollars of funding today. 2/3 of Indian enterprises are expected to get started with an AI initiative. And while we're
Nishant, sorry to interrupt. Hello, Nishant. I would request Guna to please take over. There is some problem. Nishant's audio connection is gone. Hello, Guna.
My name is Guna. Hi, I'm Guna. So good afternoon, everyone. Sorry for the technical difficulty. I think Nishant is having some concerns on his line. Let me just continue where he left off, right? So the key challenge here, if everyone looks at, if you want to look at business potential, you want to look at deploying AI, the key challenge here typically is how do I bring data to the party? If I can bring my data to my machine learning, or rather, if I can bring my AI to my data, then I will be able to actually achieve a exponential benefit to my business. So to do that, right, you need to look at a few things. So one of the key things is how do I make my data ready for AI? And to do that, I need to be able to collect my data, and that does not always mean moving all of your data to a data lake. The key word here is making your data simple and accessible across your organization to be able to implement AI at various levels. And you need to be able to organize the data. One of the key challenges that all data scientists or all organizations have, as what Nishant had explained earlier, the challenge is in getting value from the data because the data is not organized or structured. You can't expect business users or data scientists to understand column names, table names, or navigate through the wide range of data that you may have within the organization. And 3, you need to be able to secure your insights, which is your governance piece, but at the same time, how do I actually make this insights, right? If I'm trying to deploy AI, how do I make this accessible across my organization? I do not want AI to be the privy of a selected set of few people, all right? Then I need to be automated. I need to be able to deploy this AI across the organization, like I said, not in just in the selected data sets or selected markets or selected departments. And I need to be able to relook at the way I organize or the way I run my business. To avoid being digitally disrupted, you need to look at digitally disrupting your own business and the way you reimagine your business. So all of this requires not necessarily a cloud model, but it's going to get deployed on your private cloud. It can get deployed on, for example, an IBM cloud, or even a third-party AWS or Azure cloud. So as an organizer, you need to be able to modernize to a point where you are leveraging multiple clouds for both the agility and the simplicity. So one of the key quotes here from an MIT Sloan study is, no matter how much or how sophisticated your AI algorithms are, if you have bad data or you don't have access to data, it will break. In one of the earlier webinars, we actually talked about a model where if you train the data on if you train your models, your AI models on bad data, it will give you the wrong results all the time. So you need to be able to actually not just train on good data, but the whole process of collecting data, preparing the data is the most time-consuming component of any implementation of AI. Because as data scientists try to implement without access to the correct data or trusted data, you actually end up in a situation where even the best model doesn't work. That's why the phrase, there is no AI without an IA, or information architecture. And the same MIT Sloan study says that a lot of organizations, 81% of the organization don't understand the data. Not just not access the data, but they can't understand the data. What's the meaning of this data? When he says customer number, what does it really mean? Where did the data come from? Who are the people who are using that data element? So for me, to build an AI model, I need to not just have access to the data, but I need to be able to also understand what the data is. So you need to look at how I prep my enterprise data, right? Whether it is my on-premise data, is my cloud data, is my SAP data on a private cloud or even a public cloud data. It could be IoT data, social data. It could be any form of data. But being able to take that data, make it easy and accessible for my AI users, while at the same time, I need to build a trusted foundation where people understand. Like I said, it's not just access, right? It's understanding where the data is coming from and how they're all related to each other. And based on that, I build trust where people understand and trust that data, that this data is clean, of good quality, and where did the data come from? Who else has been involved in that process, right? The data lineage. And once you've organized the data, then I can look at how do I scale the insights on demand as required, different users, whether my apps developer, my data scientists, my data engineers, how do they all participate in this democratic process of data science? So what we are talking about is in the process of making data ready for AI, you need to look at how I can deploy a cloud-native data architecture while at the same time looking at my whole workflow with AI. And if I can improve and automate a lot of the workflow components, then it makes it easier for us to deploy AI across the organization. So let me touch quickly on these three components, right? The collection of data. One of the key challenges a lot of organizations have is they always take an approach where I need to look at moving all of my data into a data lake or a data warehouse. The current model, what it has become prevalent, actually has created a complexity of being able to move the data, the whole governance, the security of having multiple copies of data moved to another location or to the cloud, for example, is a complexity. So to make data collection, right, simple and accessible, you are looking at things like, yes, the data should be available across the whole organization, whether it is on-premise, private clouds, or public clouds. You need to look at all kinds of data, not just structured data, structured and unstructured data, data that's in your contracts, data that's in images, videos, etc. But at the same time, it should be simple, right? You should be able to load the data or access the data and be able to access the data in real time. So if you can achieve the ability to access that data, all of these types of data, then you have actually had the first step of getting into an AI-enabled business. Second, you need to be able to organize the data. Like I said, accessing the data is important, but now I need to be able to not just organize, but understand and trust the data. So having an ability to access the data based on your, for example, your persona. If I'm a data scientist, I need to access certain pieces of data. If I'm a data engineer, where I'm preparing the data, or if I'm a marketing department, how do I and what do I need to access? So not just accessing the data, but being able to understand and use that data or the models that are being built by my AI teams to deliver better value. And one of the things here is, and because organizations change so often, one of the key things is that it is very difficult to build all of these metadata models manually. So you need to look at things like machine learning or AI implemented within your governance model. How I can actually have the system, every time a new piece of data element that comes in, it should be automatically classified, automatically categorized into the right area so that the users can use that data in a very relevant manner. And lastly, being able to analyze, like I said, whether the data science department, a marketing department, or a supply chain department wants to access the data, he wants to be able to visualize it, for example, or just monitor an application of the data. You should be able to actually access all of this information, analyze it across the organization. It shouldn't be an area or focus of just only the data science department. So to make AI pervasive, you need to be able to scale not just the models and the AI, but also how you deliver that insight across the organization, the way you deploy it. So that's why the term democratizing data science is really a very common or very critical aspect of an organization trying to deliver value out of AI. The other key element, which is a little bit more on the technical front, one of the new things that everyone's talking about is containers. 5 years ago, 10 years ago, when people were moving away from monolithic systems, VMware and virtualization came into the picture. But now what's getting bigger is the whole concept of containerization. And one of the reasons why containerization has become very popular is because it is very easy, right? I can assemble my data, my whole data pipeline to drive value very easily. So while organizations struggle on a regular basis with how do I access my data, or is it trusted, etc., but containers help organizations become more flexible or agile by literally bringing the cloud technology both on-premise as well as giving them the agility within the enterprise. So as organizations start moving with containers, it allows them to implement a cloud-native architecture. And this the whole thing is actually built on open source. The key thing here is Docker for containers and Kubernetes for the orchestration layer. So by being able to actually deliver a lot of your analytics and your data as a microservice, then literally you can actually connect application to microservices just to connect and call a model, call an application very easily. And that brings down the overall complexity because everything becomes a microservice rather than a monolithic application. By containerizing, for example, workloads, you can actually scale up and scale down depending on what your requirements are. And likewise, you can deploy them whether in your enterprise or across a global cloud or even across multiple clouds. So this gives you an ability to actually take all of the data, right, regardless of what type of data, and exposing the data and the models and the AI as a microservice that can be containerized and delivered anywhere, right, on-premise or on the cloud. So our vision is, as organizations start currently looking at a lot of SQL, and everything's about SQL and SQL data, we need to start looking at moving to data as a utility where everything is provisioned as a virtual. So I can create a virtual data set or a virtual data mart and expose it to a department for a week or data scientist for a day or even an analyst for an hour, and then I can just shut it down. I can literally be able to provide data as a service within my organization. Then as I start getting into a DevOps kind of environment, I can automate a lot of the data science by using literally everything on demand. As a data scientist wants to access a piece of data, some piece of code, some microservices, we can build those applications literally dynamically on demand because everything would have been automated. Then you start looking at pervasive AI, where ML is built into everything, whether you're looking at your entire analytics stack as you're building applications, you'll be looking at embedding AI into everything that you do, automate everything that you do by using AI and machine learning. So IBM is really very much focused on enterprise AI. And when you look at IBM, a lot of organizations understand we've got Watson, and Watson does a lot of the cognitive computing. But if you look at from a enterprise perspective, we use our data, or you use your data to build an application, deploy it, whether it's on single cloud or on multiple clouds. You start implementing, as you go up the chain, you start looking at machine learning, you start looking at Watson Studio to build your cognitive applications. You start looking at, for example, APIs for vision, for image recognition, speech recognition, conversational APIs. And then you start building custom unique applications, for example, for risk and compliance, or GDPR. And you'll be building those applications, leveraging all of these APIs and all of the data within the organization. And because IBM has invested a lot with open source, a lot of the open source vendors, and IBM has built this technology, like I said, on Docker and Kubernetes. We work with people like Caffe, we work with a lot of libraries, for example, like TensorFlow, H2O as vendors, Jupyter Notebooks, to actually build an integrated framework for you to be able to deliver and deploy AI within the organization. And I'm going to be talking about one of the models in terms of how to build and develop the organization, enterprise AI. So when you look at data, right, I talked about this, the blue stack, where we're talking about data, how you ingest the data, how do you collect the data, how you organize the data, the governance piece of it, and then you do your analytics on it. But as you start looking at all of this whole data or data pipeline needs to be built, and it's not a simple process of building these components, right? So what we've put together with the open source community is actually build a whole stack so that you as a customer do not need to understand the complexity behind it, whether it is the actual open source standards, whether you're talking about Apache or you're just talking about ODPI as a standard. Then you start looking at the community accepted standards like R, Python, etc. Hadoop. How do you integrate those components in there? And then working with partners like, for example, H2O, Datamier, etc., right, to build those applications with you. So this whole open ecosystem is founded on the concept of open ecosystem, which is everything is and should be built on open source. So that's how we've actually built an entire solution for a customer called IBM Cloud Private over Data. So as I talked about, how do I collect the data? How do I access the data? How do I understand the data? It doesn't need to be me installing 25 different software components on 25 different servers and managing these 25 different servers. A cloud private model, or IBM Cloud Private for Data, what we've done is built completely in open source, Kubernetes and Docker. We've actually built a stack which allows you to leverage data as a microservice, governance as a microservice, analytics as a microservice, data science as a microservice. So with that, what it allows us to do is actually, it makes it easier for an organization to do for example, an AI project very easily by going through each of the rows in terms of accessing data, etc. So a lot of organizations look at Watson Studio as the premium tool in the market for cognitive application development for AI machine learning. We've been ranked very high by Gartner, by Forrester, etc. But one of the things is that, yes, you don't have to develop everything on the cloud, and that everything on the cloud remains separate from whatever that you do on premise. What we've done is we actually integrated both our technology components together such that we allow for organizations to build and deploy, for example, their models or the AI on IBM Cloud Private for Data, and at the same time share the models, share the metadata, share the data catalogs with the cloud or the public cloud implementation of Watson Studio. So this is a seamless integration that allows customers to connect across both environments. So what are the typical use cases for an organization that's trying to look at AI within the enterprise, right? So first one is typically you need to start looking at how do I accelerate my journey? And like I said, the key thing comes down to with ICP for data, it allows you to easily access a model where I can connect the data without having to move my data. So by using federation and virtualization, I can now make it easy for my analysts, for my developers, my data engineers to access that data. I want to be able to modernize my applications, right? So as I'm looking at modernizing my applications, then I'm looking at how I deploy, for example, my application as a container. Then I can then make it very easy to deploy new modern applications, replacing my old monolithic legacy applications on a container. I can then start looking at how do I actually put together collaboration within my team. So like I said, one of the key things about a DevOps kind of development methodology is about how I can actually get my teams to work together. And when I talk about my teams working together, then I need to be able to share models, share APIs, share pieces of application code so that I can connect my whole organization together to build this. And lastly, or second last thing is monetize my data. So as you start looking at machine learning, you'll start realizing that there are a lot of new things and new opportunities, not just to improve productivity, but also to look at monetizing my data to drive new value out for my business, new revenue models for my business. So when that comes up, then there's an opportunity for you to actually monetize a lot of this data. And lastly, the whole governance piece. The governance piece has taken a big image of its own, a very big focus, primarily because of GDPR in Europe, but that impacts everyone, whether it's personal privacy, data, PPDA, etc. Everyone is looking at how do I ensure that my data is compliant, my policies are being followed, adhered to. So I can actually look at deploying machine learning and AI to implement a data governance policy. So, and what I'm going to do is just, like I said, to try and deploy a AI within enterprise and access data, to build a project on your own, it becomes fairly difficult because, like I said, you do need to know a lot of the plumbing within the organization. How do I connect? How do I access the data? So I'm going to go through 4 roles. So, for example, a system admin who's more of an infrastructure person, looking at how actually he or she will support infrastructure. Then I'll go on to a role of a data engineer who's the one actually helping to prepare, access the data. And then a data curator who looks at the quality of the data and building an application for it. And then I have a data scientist who's going to build a model and train the model. And I'm going to walk through the whole pipeline of how this would typically work in an organization. All right. So maybe we can go to the next slide, which is a video. And what I'm going to talk about is a system admin where what she's going to be doing is responsible for acquiring hardware, deploying software, and managing capacity. She wants to know how the system is running, and she needs to be able to look at the entire infrastructure. Right? She needs to know how and all of the infrastructure is running. All right. So can we move to video 1? Hello? Just give us a short while. We're playing the video.
Hi, Guna, can you repeat again which demo needs to be played?
Demo 1.
Okay.
Okay, so as I was saying, as a enterprise system admin, you can log on to the IBM Cloud Private over Data. As you log on, you can actually see all the instructions are there. It allows you to manage the platform in a very simple, easy to use UI. If you can't see the video very clearly, please maximize your screen using the second bottom button that allows you to see the screen in full screen mode. So it allows you to monitor, for example, my whole environment. In this case, she's looking at all the various catalogs and services that she has. She looked at the utilization. She wants to deploy an application. For example, I'm just picked DB2, but it could be any application that's available as a Docker. She sees the container. She wants to deploy the container. She can instantly, it takes her seconds or minutes to be able to deploy a DB2 instance or a database instance within an environment. She can choose how many CPUs she wants to access to it, how much of memory, how much of storage she wants to allocate to it. All of the backend is actually effectively managed by the ICP, the Docker and Kubernetes. With a rich catalog of all the products and containers, what you can do is it makes it very easy for her to start up a database environment or start up a any environment. So I'm just using an example of a database, but it could be any instance can be easily provisioned. So this is the system admin kind of function where instead of typically procuring hardware, taking 3 days to 5 days, install the software, and then being able to take advantage of it, now you're looking at literally being able to provision things within minutes and seconds. The second role you look at as you move forward is once the systems are available, the data engineers then start looking at how do I actually take the data, how do I access the data, how do I improve on the data, how do I clean it, manipulate the data, to massage the data, right? So I want to talk about a particular example which is a bit more complicated, which is real-time data. As many of us start moving towards real-time data, one of the biggest issues is not the data that's landing batch and the evening and then I'm massaging it. One of the biggest challenges is that I'm starting to look at data that's streaming, whether I'm starting to implement IoT kind of environments, video cameras, for example. I'm actually getting data, for example, my core banking, literally now real time. What do I do with it, right? So let me go on and show an example of how a data engineer is now able to look at a real-time data feed, monitor it, and then act on it, right? And how do you play with the data? So E.T., can you play the second video, demo 2? Again, this is the same platform. So as a data engineer, you come in, you see a console. I'm going to be talking about real-time ingestion of data. I'm actually just running it across 3 nodes. As you can see, as the data starts streaming, all the person needs to do is define the landing zone where I want to create a landing area for the database, for the data. It could be Hadoop, it could be database, it could be Oracle, it could be DB2. But as you can see, the data really streams really fast and is able to, we're using a combination of Kafka and IBM technology to be able to ingest this data. And in a 3-node environment, you can actually ingest something in the range of like 4 to 5 million rows every second. So this is really a high-speed data ingestion layer, which for a data engineer is very critical because as the data is being ingested, he can monitor, for example, the throughput that he's getting or see alerts. For example, if any of the nodes is not performing and there's an issue on the nodes, he can actually manage by exception by looking at the data and the exception is triggered. And he can then, for example, restart that node, access that node, and do work on it, for example, the data. He can actually access that data and then start manipulating it, for example. All right? So effectively, that is an example of a real-time ingestion of data, but it could also be a batch ingestion of data. Then once I've actually landed the data and I've got the data, I actually got a data steward. All right? Many organizations actually may be the same person, but for the purpose of discussing the different roles, I'm now looking at a data steward who's looking at the data and curating the data in the sense that, for example, are there missing columns? Are there missing data? Are there invalid data? So I'm going to show an example of how a ICP for data would help a data steward start looking for missing data or automatically classify new data elements. E.T., could you play the third video? So as I said, again, the same console. As a data steward, you'll be looking at, there's a lot of rules that have not been assigned. There's a lot of data elements that have not been classified. So it's very easy for the person to just put in a new rule, look at all my data elements, automatically classify the elements that have not been classified. In this case, I'm looking at, for example, physical addresses. I can actually get the system to classify it. It sees that zip code is automatically classified. If I want to change it, I can reclassify it, and I can reclassify it, and the system learns again. It also helps me identify relationships across data. How is age and customer, etc., all of this, how are they related? Which are the elements that make up a computed data element, for example? It allows me to see all of the relationships. So, because as a data scientist, or if I'm trying to build a machine learning model, then I need to be able to understand the data. So it allows me to automatically classify. So as you start bringing in, for example, new data sources in an organization, you do not have to spend a lot of time trying to understand the data, because the machine learning built into the ICP for data actually automatically classifies the data for you. And once the data is automatically classified, then now I want to give it to my data scientist, who can then access the data to build these models. So one of the challenges we talked about is all of the things typically that we've talked about, the roles typically are being done by a data scientist. But if you are able to look at the different function, as a data scientist, you are actually looking at hiring a data scientist for the purpose of building models. And as we said, there's a 400% increase in demand for data scientists in India. And last thing you want to do is get a very experienced data scientist who's spending a lot of time on preparing data, cleaning data, etc. So now I've given him a data set which is clean, is automatically classified, he knows what the data elements are. Now he needs to try and build a model, right? So I'm going to go to the next demo, which will walk through the demo of how he's going to actually look for data, access the data, and build something. So demo 4, please. So as a data scientist, right, so first thing he'll be looking at, where is my data? So he can actually search for data. For example, in this case, he's looking for customer data, and he's looking for a customer churn model. He can see all of the data elements that are there. He can create a new project that he wants to do. So he's creating a customer churn model, and he wants to create a project for customer churn. He can look at the customer churn model. He can look at the various data sets. All of these are available within a notebook. So what his data sources are, he can connect to those data sources, look at his notebook. He can set up the whole environment within a notebook. He can then start looking at, for example, how do I access the various data elements, right? So if I want to connect to a data, he just needs to look at the catalog and see what are the data elements that are available. And from there, he can automatically pick it up and then start deploying that data into my model, into my application. So once I've accessed the data, as you can see, it's as easy as just connecting to the data. I can do all my visualization within my notebook. So I can explore the data, I can visualize the data, I can train the data, all within my environment of the notebook. So this allows the data scientist not just access the data, but he gives him the productivity tools to be able to use, for example, RStudio or Python or R for him to build these applications all within the framework. So you don't restrict him in terms of what he wants to use. But at the same time, you have the corporate governance where he's building that model, training the model, and then once he's built it, he's publishing it into the catalog. So he's built a customer churn model and he's deploying it. All right, he's publishing it. And as an organization, right, what you don't want as well is you don't want organizations to start deploying models ad hoc. So we've got a data scientist now built a model for customer churn by connecting the customer data, etc. And once he's built the model, he's ready to publish it. But when you want to publish it, you probably need to have a governance process, a curator who looks at all of the models that are being published to be able to accept, agree, and authorize it, right? So we go to the next demo, the 5th demo. And this is where I'm going to show how ICP for data allows the person to track the data, look at the different models, approve it, etc. So demo number 5, please. So again, same UI, but based on the persona that comes in, the UI looks different. I know it was a bit difficult for you to look at the UI earlier, but literally, depending on the persona, the UI will change based on your roles and responsibilities. The person can look at the model that the data scientist has built. The data model looks good. I agree to it. I approve it, and I publish it. So the whole workflow, right? When I said automating the process of embedding AI within the organization, the whole process, giving visibility to the people, what's in the catalog, what are the models that are available, what are the applications that are available, what are the assets that are available. Based on that, I can look at those assets after I've published them, and in a published catalog, I can access those models and deploy them. So effectively, you look at it as an organization. Now, you actually have the flexibility to be able to deploy a infrastructure completely on Docker and Kubernetes. So you don't need to have multiple servers running multiple things. And as your demand grows, you can scale up. If I need more database, I can scale up increase the number of database nodes by provisioning more. Like I said, it takes minutes and seconds to deploy a new, for example, a data node, whether it's Hadoop or structured database like DB2. I could easily govern the data, understand the metadata. I can do my data manipulation. I can do my massaging my data, get my data engineer to manage all of the data, publish it. Data scientist build a model, again, get an approval. If the data scientist doesn't have access to the data, he can actually have a internal workflow that says that I don't have access to customer data. Please, if you are the owner of the customer data, please approve it. So the whole process of getting access to data, governance, and building the model, we've made it so simple that literally it becomes a matter of minutes and hours for you to deploy a new model rather than going through the whole process of spinning up new cycles. So what IBM has done is we've actually are recognized as a market leader. I think a lot of organizations do recognize IBM as a leader in Watson, etc. But the whole, what we call multimodal predictive analytics and machine learning, IBM is recognized as literally the leader in this game by Forrester. So it is designed not as a PhD type level tool, but rather it's meant to be for making a collaborative environment where both the experts, the data scientists, everyone can work together to build a model. So it's balanced from both a data science team perspective as well as the enterprise, and at the same time is built on open source. So we've got a lot of customers that have actually went ahead and have gone on this journey with IBM. Both global customers, like for example, Electrolux, Volvo, but we've also done a lot of work in India itself, for example, with SBI, Genpact, where we've actually helped them implement AI within the organization by either helping them get access to all of the data, helping them with machine learning, getting them to build models collaboratively, modernizing their workload as they move towards cloud private, as well as automating compliance, etc. And the key thing, right, is about data, accessing all of the data regardless of where they reside. So if you look at the next generation, not just currently, and if you look at all of what the analysts are saying, whether it's Gartner or IDC, etc., IBM is recognized as number one in new technologies like artificial intelligence, blockchain, quantum computing, Internet of Things, etc. So IBM is recognized not just that we are the right partner for you to work with now, but we also recognize as a partner that you can build your business on for the future. So to help you get started, I have an offer for you, which is effectively, if you have an AI use case in mind, right? If you have an AI use case in mind, and we are offering basically a free consultant that will be able to work with you. We can help you build that model. We'll get you access to an IBM Cloud account, give you some credit to help you build a mock-up on that use case that you're looking at. So it's an offer of a free consulting. Just fill out the feedback form for us, and based on that, and request for a demo, and we will work with you to build that use case to see how it's best done. All right. So just a final thought. I just wanted to say, a lot of organizations, and this is interesting because a lot of people believe that AI will replace people and leaders. Actually, it doesn't. Effectively, what will happen is that AI will not replace leaders. It will replace leaders who don't, all right, if you use AI, you will replace someone else who is not using AI. That's the fundamental difference. It's an augmented intelligence rather than truly standalone artificial intelligence. So managers and leaders who use AI will replace those that are not using AI. So with that, I would like to finish my presentation. I've seen a couple of questions, and let me start picking up maybe a couple of questions that we can then start discussing.
Thank you, Mr. Chilappan and Mr. Arora, for an insightful session. I hope it has been a very useful time spent by our audience. I would request you to please take questions from our audience. We have quite a few questions in our chat window. Dear delegates, you can please raise hands. We shall unmute your line so that you can have a live chat over a call.
So one of the questions that came up is about how AI can be leveraged for sustainable computing, or specifically in India, where India doesn't have an AI policy. What strategy can a startup look at for future collaboration, right? See, the question here is that it's not so much of a concern of how AI is or cannot be leveraged. AI will become pervasive, i.e., it literally will be embedded in everything that we do. So whether we are talking about walking to a store and the store automatically knowing that this is what Guna typically buys on a trip to a store, it is effectively a model where you can actually, based on history, based on typical patterns, the machine can make recommendations based on everything that we do and everything that we've done so far, whether it is based on our browsing patterns, whether it's based on my previous purchase, based on all of these models, the system is able to recommend. So it is not about having an AI policy in place, etc. There are some things where the government does play a role. For example, we talk about driverless cars, right? Self-driving cars. Then there is some policy involved in terms of what happens when there's an accident, or what happens if AI recommended something and that something turned out to be wrong. Then who holds responsibility? So there are some governance issues, and I totally agree that there are some areas, but more often than not, the way that we see it, we are still maybe 20, 30 years away from a model where AI will do something completely on its own. The show that you talk about, like whether Terminator, the show is literally years away. But what is happening now is that machine learning model or AI within the enterprise or within a business helps the decision-making process by giving more appropriate recommendations to someone who's going to make that decision, or simplifies the decision-making process, or simplifies a salesperson at a retail on the products to recommend. So AI at the moment, and the way it is playing out, will be more of a augmented intelligence rather than a pure AI model. And I think a very interesting question, can AI overtake and control our minds? Like I said, at some point, this is what the movies, or at least Hollywood movies, they always threaten about sentient beings being created by AI. My personal view is AI will continue to be very narrow-banded, i.e. the computing capabilities that are available now actually do very narrow-banded AI, i.e. a specific function. I can drive a car. Can the computer driving the car take over the world? No, but it would be probably a better driver than a person who doesn't talk on the phone, doesn't SMS, and drives within his lane all the time, right? So he'll be a better driver than a person, but will he be a better person? That is very far away, and I think for the time being, we can just watch the shows that talk about Terminator, etc. But I think the phase in which AI takes over us is still very far away. One of the other questions was about data quality. I can't state it often enough. Data quality is really, really important. With bad data, there was a study done by, I believe, MIT, I think if you search online and you look for MIT Norman Bates, Norman Bates was the guy, the character in the show Psycho. And what MIT did was they trained the AI engine. All right, it's the same AI model. They built the same model, two models, and they trained it with different set of data. One set of data was effectively all the bad images, murder, stabbing, killings, blood, etc. And the other set was just every other picture on the internet, gardens, sea, sunset, etc. Then both the models are exactly the same, just they've been trained by different sets of data. One very violent data, one a general set of data. And when they gave it pictures to see, those ink blot pictures, what the machine learning model predicted, what it was always something about this is a picture of someone killing someone, when actually it was a picture of something natural. So the AI model is built to learn something. It's very much like us and our children. So those who have children, you would understand, we are teaching our children what's good, what's right. If we teach our children all the bad things, then guess what? Our children, if they turn out bad, then it's all of the experience that we've imparted to them. If we teach them all the good values, then we believe that they will turn out good because everything that they respond to as a stimulus will be the good model. So machine AI are effectively the same. If you get the right data, good quality data, a good sample size, or in fact all of your data, then the systems would work in a better manner as opposed to using, if it's bad quality data, then you have issues. So if you look at ICP for data, we've put in a lot of emphasis in the middle part, which is how do I bring the data in? How do I ensure my data is clean? If there are two data elements that say customer, which is the data element that I should trust? And which is the data element which is more appropriate? And if the data element has been tampered with by someone, how do I know who tampered with the data or which system process modified this data element, for example? So I need to have a good data governance model, right? The quality and the way I bring the data and I manage the data is really, really critical to do a true AI or a good AI. Okay, this is another interesting question. How does AI using IBM Cloud Platform differ from other cloud platforms? To be honest, a model is a model. If you build a model on R or Python, it's effectively a model. But typically, when you build a model on a different cloud platform, then one of the key differences between IBM Cloud Platform and competitors' cloud platform is that same model can run on-premise. IBM has the ability to run the same software, same technology. You can run your models on-premise, accessing data on-premise without having to move everything to a public cloud. So we differ in the sense that we do have a hybrid model where you can put everything on-premise or you can put everything on cloud. So we have the ability for organizations to divide and conquer. Second thing is that we focus a lot on the plumbing. Our heritage is enterprise, and therefore, as an enterprise organization, if you want to start looking at pulling data in, a lot of the plumbing is already done for you. So when you look at IBM Cloud Platform for data, IBM has already done all of the heavy lifting, i.e., how do I access the data? How do I connect to the data? I don't need to move the data. I don't need to have another tool to try and understand how the data works. So we've built it into like literally an integrated suite, which you can deploy as you see fit. If you say, I'm not interested in the visualization, I'm only interested in the governance, then I can deploy all my nodes just for governance and data quality. But if I feel that I'm comfortable with the data quality, but I want to deploy all of my nodes or more of my nodes towards data science and my machine learning algorithms, then I can selectively deploy. And like I said, when I showed you, then the amount of time it takes seconds to minutes to deploy a new data science node, a machine learning node, or a data node. So we've done a lot of work around those components. And each of those components, whether you look at the Forrester or Gartner, IBM is in the leaders quadrant, whether it's a data platform, whether it's the integration layer, whether it's the governance, whether it's data science, we've got the best of breed in every segment of a the journey to the AI, right? On the ladder to AI, whether data element, the governance element. So we've actually got the market leading products and technology for each component. And with ICP for data, you just kind of put it all together that makes it easy as a customer for you to consume it. Maybe this will be the last question I'll take. Consumer AI models. Okay. I think looks like more like a comment, not a question. Consumer AI models can't even get autocorrect right? So autocorrect, we all of us type things, and it's a joke, but my name is Guna. Almost every phone autocorrects my name to Gina, Gina. Maybe in the US, Gina is more common than Guna, Guna. But this part of the world, one thing I'm for sure, there's more Gunas in AP than Ginas, right? But it autocorrects. So the machine learning model that Apple or Samsung and all of them have deployed for predictive keyboard is a very simplistic algorithm that if you type in something and the next closest is Gina, it goes towards it. The machine learning model can be implemented such that you can actually build a model saying that if if the word Guna keeps appearing, and it keeps appearing more often than Gina, then you know what? In all likelihood, it's more likely to be a Guna than a Gina. So instead of auto-correcting it to Gina, I should auto-correct it to Guna. So that model is the implementation of AI rather than a problem with the AI technology. It's not a consumer AI technology limitation. It is a predictive algorithm that was built by those companies that are manufacturing the keyboard software or the keyboard component. And they did a simple lookup, just that if you type in anything that looks like Guna, it should be a Gina, not a Guna, right? So, okay, maybe I've still got one more minute. I'll take one last question, right? So I'm sorry about this, but I'll take the last question is, how does AI on IBM Cloud going to help manufacturing? And it's an interesting question because I was just talking to a manufacturing customer in a high-tech industry just earlier this week. So there's two aspects in here. So in any organization, the implementation of AI typically falls into three areas. In all manufacturing companies, I will have a sales and marketing function. In a sales and marketing function, understanding what my customers buy, understanding what marketing campaigns I should run, what price I should sell, how much I should sell, where I should sell, which store should I supply to. So that's the customer end of it. And AI has got a very proven case study around, for example, whether the auto manufacturer designing, you know what, I should make more red cars or more blue cars. I should make more cars with turbo engines or non-turbo. So understanding customer buying patterns and then deciding your product strategy, etc. That's on sales and marketing. But the manufacturing, the actual manufacturing base is where I think there's a lot of opportunity that is actually coming about because of things like IoT. A lot of manufacturers, as they start getting towards smart manufacturing techniques, they start having sensors. But when the sensors start giving them data, as in the temperature here was too high and therefore the paint will not be good, me detecting it early means I can fix the problem. But that's my manufacturing automation, right? My MES system. But once I have that data, I can start building models to look at if the temperature is too high and at the same time it took 3 seconds too long on this shop floor on this machine, then I can start looking at what is the likelihood, what is the next step I should do, what kind of corrective action I should do, or should I stop my production line, for example. So using AI to automate and improve the efficiency of the yield on my manufacturing line or on my plant floor actually help me improve my yield, etc. So there's a lot of good opportunity, or in fact a significant opportunity, because the shop floor is one of the areas where it's least automated. But if you look at what organizations like Samsung and Toyota and all of these companies are doing globally, is they are looking at using AI to automate their machine floor. So that's on the machine floor piece. And then on the third area, on the whole issue of fraud and risk, a lot of organizations are start looking at how do I actually analyze all of this data such that is there a fraud, for example, customer service. a guy who keeps calling up to say that if handphone is faulty, he wants a one-to-one replacement, he's leveraging his warranty agreement one too many times. Can I see whether there's a fraud going on? Because is he abusing the system? He bought one machine, but he's sending 3 machines for replacement, for example. So looking at, for example, fraud, risk, compliance. We've done a project for a large engineering company in Australia where they've actually looked at documentation. So being able to scroll through all of the documentation for engineering and then help the on-site engineer look at what is wrong with that valve or the sensor so they can fix it. So instead of having engineers with 20 years of experience, even an engineer with 5 years of experience with the right tool, with the right AI, can now go on-site and actually detect the problem and fix the problem, even though he is not as experienced as a 20-year-old engineer, right? A 20-year experienced engineer. So there are a lot of things that are actually happening on manufacturing, because I think when you look at manufacturing 4.0, industry 4.0, it requires a lot of smart in it to be able to drive the efficiency in the manufacturing process. All right. I've got a request for some white papers and red books. So we will get back to you with those documents. And in the feedback form, if you can specifically put in a remark or a comment, then that will help us get back to you as well. So again, my name is Guna. I will just put my email here to everyone so that you can look at it. And if you have a question or anything that you'd like to send to me, feel free to drop me an email. And that's my email ID, Guna, Gunasek @sg.ibm.com. All right. So thank you, everyone. Thank you for the call.
Thank you, Mr. Chelapan. On behalf of the Economic Times, I would like to thank all the participants for joining this webinar. We hope it has been a useful time spent with us. Thank you again for joining the Economic Times live webinar powered by IBM.